The next test we're going to talk about is called the P-series test. There are going to be some things I'm going to be saying in this video that aren't going to make much sense until we get through later videos. But I like to talk about this test at this point because this is the point I would normally be trying it if I'm trying to show a series converges or not. So the P-series test is a test for something called absolute convergence. What that means is that my terms must be non-zero. The term, it's non-zero is a better way of phrasing this than saying the terms must be positive, because if we say the terms have to be positive, that means I'm not allowed a term of zero. So non-zero and positive. Or my terms are greater than or equal to zero. The way we can force that to happen is by taking the absolute values of our terms. So it's absolute convergence. So this is of the form when I have a series where n's going from something to infinity. My top doesn't necessarily need to be 1. It just needs to be constant. And then my bottom has to be in the form n to the p. If n is being raised to, so if I have a constant over n to the p, if p is bigger than 1, it converges. Sorry, I should note, in order for this to work, the top has to be a positive constant. This is really a special case of what is the integral test, which is a test we'll get to in a later video. But kind of remember, terms have to be positive, or non-zero positive. Because if I have 0 here in this, it's not a P-series. Numerator can be any constant. Special case of the absolute value of the integral test. So some examples of this. There's a well-known series that's called the Harmonic Series. Sorry, that looks too much like a negative sign. It's meant to be like a little indent here. The Harmonic Series is 1 plus a half plus a third plus a fourth, so on, plus 1 over n would be my general term. So if I did this in summation notation, that would be our series. Notice I have a constant on top and to a power on the bottom, because p equals 1 and 1 is not greater than 1. This diverges. That would be by the P-series test. If you were to graph this, it doesn't look like it diverges, but this diverges incredibly slowly. It takes an incredibly long time for this to start running off to infinity, but it does diverge. Second example of this, if I have this series where n goes from 1 to infinity of pi over n to the 3 halves, pi is a constant, over n to a power. My power is 3 halves. Since 3 halves is bigger than 1, that means that this series converges by the P-series test. Again, you don't really have to name the test as long as you're showing the work that leads to your conclusion, which you would need to do even if you were naming it. So that's why I'm putting the names of these in each of the examples in parentheses.